Hello everyone, welcome back to the class. So this is going to be the part 2 of your chapter carbon and its compounds. In part 1 we have already discussed about the carbon. I have given you very detailed introduction of carbon where I have explained about the various characteristics of carbon, that carbon is known as the tetravalent element and it is known for the catenation property which helps the carbon to get or to form various covalent bonds and get attached with the elements in a very versatile manner, right? And then we also have discussed certain allotropes of carbon such as diamond, graphite, and where else the carbon is being used for our day-to-day resources. If you haven't seen that part 1 video, I would suggest you all to first see the part 1 where you will get the whole description about the chapter, and then please come again to see this video. Then we have also studied about the covalent bonds. So as in the previous video, we have taken certain examples of covalent bonds. So this is going to be one of the example that is bit different with the other examples we have taken in part 1. So we will take here the example of carbon monoxide. So we are going to form, as you already know that we have studied about the electron dot structure and the structured formula. So we will see like in the both terms how we are going to form the covalent bond here. So we already know that in carbon monoxide there is a carbon, and mono means one atom of oxygen is here present. So we configuration is 2 and 4 and oxygen will get 6 as the valency. So we will draw a carbon and oxygen here, whereas we can see that 1, 2, 3, 4 electrons we have drawn around the carbon, and in oxygen likewise we will draw 6 electrons around the oxygen. So here if you can see, the carbon requires only how much? 4 electrons to complete its outermost shell, and oxygen requires 2 electrons to complete its outermost shell. So from the previous section we already know that covalent bond is formed by the two elements so that they can stabilize their outermost electronic shell, right? So in order to have the outermost electronic shell balanced, we need at least 8 electrons in the outermost shell. So we already know that there are 6 electrons in the oxygen, but these two which are vacant, which are useless for the oxygen, they are not going to participate in the covalent bonding, but they do require to take part in the covalent bonding. But here when there is useless and they are not being used, until then they are known as lone pairs, okay, that afterwards will get involved in the covalent bonding. And when their involvement takes place in the covalent bonding, then that covalent bonding is no longer named as covalent bonding, but it is known as coordinate covalent bonding. So here let's see how does this happen. So carbon in the surroundings we already know 4 are there, and oxygen we have drawn 6 electrons. Now as you can see in this picture, this on the outermost shell when they start having the covalent bond, so you can see 1, 2, 3, 4, 5, 6 elements are getting for the oxygen, and 8 electrons of oxygen are being completed. But here as you can see there is not a case for the carbon because it is not able to stabilize its outermost shell likewise, right? So you can see what happens, these lone pairs get down and start getting involving in the covalent bonding. So like this we can see 3 pairs of electrons is being shared, and that is why there you can see the triple bonding will form between carbon and oxygen because of the 2 lone pairs which come down and participate in covalent bonding. Since the lone pairs are getting involved in the covalent bonding, this is known as coordinate bonding. And in coordinate bonding you can see you can represent the coordinate bonding like this with a one-headed arrow, right? So you can see these 1 pair of electron is coming from the carbon itself, electrons is coming from the oxygen. So likewise they form triple bonding, alright. So that is known as the coordinate covalent bonding, which can be seen in carbon monoxide. So this is one of the example for the electron dot structure, or you can say the structure formula, where you can see the covalent bonding, and this one is coordinate covalent bonding. Well, for the other examples, if you want to see, we have already discussed about the single covalent bond, where I have given you example of methane, and then we talk about double covalent bond, where I have given you the carbon dioxide example. You can see in the part 1 section. Now we are going to see about the compounds of carbon. So first of all, we have to begin with what are compounds actually. So when two or more than two elements chemically bonding together, they form the compounds. I have seen certain compounds formation in the chapter 1 of class 10, where we have seen different reactions being taken place to form certain compounds, such as combination reaction, decomposition reaction, displacement reaction, neutralization reaction, etc., etc. So now we are particularly going to see how we are going to form carbon compound. Okay. So for learning the carbon compounds, the chemistry subject has been divided into three particular sub-subjects, like organic chemistry and the physical chemistry. So when we talk about the organic chemistry, we talk about the compounds related to the carbon, means carbon's compounds we learn in organic chemistry. So basically the organic chemistry is like we study about the carbon and its compounds, which are formed by the covalent bonding, which we already have seen, means CH bonding. Then we already know that these organic compounds have certain complex structure because they are being combined with certain coordinate covalent bonding, etc., etc. So these organic compounds or the organic carbon compounds are also known as hydrocarbons because they have a bond with the carbon and hydrogen. And these hydrocarbons are being divided into two types of hydrocarbon, that is saturated hydrocarbons and unsaturated hydrocarbons, which we are going to see. Saturated hydrocarbons are known as alkanes depending upon the bond they form. Means if the bond is single bond, then they are termed as alkanes. And if they are forming double or triple bonds, then they are known as alkenes and also known as unsaturated hydrocarbons. So if we give certain examples of saturated hydrocarbons, so the natural gas, petrol, kerosene, methane, ghee, even the saturated fat, they all comes under the alkenes. And plastic bags, toys, containers, oils, these are all unsaturated. Oils, that is unsaturated fats like olive oil, or you can say any soya oil. So these are known as unsaturated fats and they form the double triple bonds. That is why they are unsaturated. And the paints, adhesive, coatings, welding and cutting irons comes under alkynes. So we will see in detail about the alkanes, alkenes and alkynes. These are the Alright, so let's learn about alkanes, alkenes and alkynes. So we already know that these are the hydrocarbons known as saturated and unsaturated hydrocarbons depending on the bonds they form. So as we talk about alkanes first, alkanes is a type of hydrocarbon we have that is having the general formula CnH2n plus 2. Now why do we need this formula? Because this formula further will help us to name the hydrocarbon. So N here will represent the number of carbon atoms, right? So N here is the number of carbon atoms present in the hydrocarbon. Okay. So depending upon the number of carbons, such as if the number of carbon is 2, so H will be 2N plus 2, which will we will get C2H2 multiply 2, which is 4 plus 2 means we will get C2H6. So in this way, if we get to see that carbon is of 2 atoms, so we will automatically consider it as eth, or while naming the hydrocarbon of alkane, we need to start it with eth. Okay. So according to the IUPAC, means International Union of Pure and Applied Chemistry, they have given this structured names. Okay. So for nomenclature, or due to them we can name the hydrocarbons clearly. Okay, and these are certain rules or the formulas by which we can name these hydrocarbons easily. So prefix is generally depend upon the number of carbon atoms present in alkanes, alkenes or alkynes. Okay, so that means N. So if the carbon atom is 1, we will start the naming with meth. If it is 2, we will start the naming with eth. And likewise, if it is 8, we will start with oct. So likewise, it will go further and further. And what about the suffix? Prefix means for the beginning or the starting we will do with the prefix. And for the suffix means how we are going to end the name with. So always remember, if it is alkane, the name will always end with ane. No matter what you are writing in the prefix, but the ending should be done with ane only. For example, if we have methane, Methane means CH4. So as you can see here, N, right? So if N is 1, so as per the general formula, C1, it will be look like this, 2 plus 2, 4, right? So this is methane. Meth because there is only one carbon atom, and ane because it is alkane. So we will say it as methane. Likewise for ethane, C2H6. So kind of you can see in the general formula, we will double the hydrogen and add 2 more. Alkanes forms the single bond only. So that is why they are considered as a saturated hydrocarbons. Single bond, saturated hydrocarbons, single bonds between carbon atoms like this. Now what about the alkenes? So alkenes, if you can see the general formula, there is no adding of plus 2 atoms, right? So it is like CnH2n. For example, if we talk about meth, so C1H2, so it will be CH2, right? So it will be methene. You have to end with ene, okay? And starting will be the same. For one you have to write meth, it, like this you have to write. And these are unsaturated hydrocarbons because they are forming double bond between carbon and hydrogen atoms like this, okay? So when we talk about the alkynes, alkynes means here you can see the general formula. When we are adding 2, it becoming alkane. We are not adding anything, it becomes alkenes. And if we are minusing or subtracting 2 atoms, it becomes alkynes. So its starting will be the same, methane prop, and its ending will be ine, Y-N-E, right? Like this, C2H2O means ethine. Butane, like this. These are also considered as unsaturated hydrocarbons because they have a triple bond between carbon and hydrogen atoms. When we talk about inorganic chemistry, the inorganic chemistry does not have the carbon and its compounds. Means it do have the compounds, but those compounds are not being bonded with carbon. Okay, it deals with the inorganic compounds which do not have CH bonds. They typically shows the ionic bonding. They do not show the covalent bonding, and they show the ionic bonding, which we have already studied in the chapter 1. That means they are going to share the positive and the negative ions, two elements, then they form the ionic bonding, which include acid-base reactions, displacement reaction, etc. Mainly deals with the salts and crystals, which we are going to learn more about when we are going to learn about the detergents and the soaps. Then we alkanes, alkenes and alkynes. There is one more organic compound which is known as the functional groups. Now what are the functional groups? So functional groups are attached to a hydrocarbon. Means if you have a chain of CH bonds, then these functional groups get attached to it, and what they will do, they give the specific properties to the compound, and they sometimes accelerate the properties, or sometimes they can change the chemical properties of an compound altogether. Let's take a look about the functional groups. Okay, so let us see how we can learn functional groups. Alright, so functional groups, we have certain number of functional groups as discussed in CBSE and NCERT textbooks. Let's start. So first one is hydroxyl group. So its formula look like OH, and its suffix is all. Prefix is none. For example, if we see CH3OH, so this is because carbon here you can see only one. So we will consider the prefix as meth, okay? And because the functional group is OL, means OH, hydroxyl group is there. So we will add the suffix as OL. So it will become methanol, actually, methanol. All right, so methanol. So it's contain hydroxyl groups attached to other carbon atoms, and this functional group's typical name is alcohol. IUPAC is hydroxyl groups and the functional name is alcohol. Then the second number is carbonyl group, which is aldehyde. So their formula is CHO. So wherever if the chain has CHO at the ending, so we will know that it is a carbonyl group, and its suffix is going to be al, and prefix is none. It depends upon the number ketone. So it is usually present in between the hydrocarbon chains. Okay, so in the CH bonding in between, you can see that this ketone group is present. For example, like this, if you can see, going to be oic acid. Likewise, here you can see there is one carbon is there, so we will call it as methanoic acid, and its ending is carboxylic acid, so we call it as methanoic acids. Ending and like this CH3NH2, so this will call it as methylamine, okay, and it comes from the amine group. And then there is an ester group in middle, it is also present in the middle, COO like this, and it form like what? Methyl acetate, okay, it is called it as acetate, O8 at the ending, right? We are going to learn more about how we are going to name these hydrocarbon chain with or without the functional group. So don't worry about the naming, we are going to practice it separately, okay? Right, chloromethane, right? Chloro, or here you can see bromoethane. Likewise, so this is coming from haloalkane group. And then there is a cyanide group, or we call it as nitrile group. Quickly see how the naming of hydrocarbons by learning the rules of writing the names. So first rule states that identify the longest carbon chain. For example, you have a chain. So this is going to be considered as a parent chain. Every branch is going to happen in this long chain. So you need to first figure out or identify which is the longest chain. So here you can say 1, 2, 3, 4 carbon atoms chain. Longest chain is of 4 carbon atoms. So the base name is butane, because you already know when there is 4 carbons, we will call it as but. And since you can see there is no double bond, triple bond is there, means it is from the group of alkane. So we will write it as butane. Number the carbon chain. So while you get the value, identify the longest chain. Now rule number 2 you have to follow. You have to write the numbers. So always remember, if you have find out that this longest chain have some triple bond or double bond in it, so from there you have to start numbering the carbons. So as you can see, here is a two double bonds are there. You can see double bond is present here. So we are not going to count our carbon or the longest parent chain from here. We have to start from here like this: 1, 2, 3 and 4. Now this is of but will come here. So but 2ene, because you can see 2 is a double bond. Presentation of 2ene is here. The double bonds are present at the 2 carbon atom. So we will write like butene, and ene because it's a double bond. So always remember that wherever there is double bond or triple bond, we have to start numbering the chain from there itself. Now the rule number 3, identify and name substituents, branches or groups. For example, we have this. So there is no, you can see there's a simple long chain and we just have written name pentane because it doesn't have the branch. Now for the number 4, if there is substituents or there is a branch, you know, in certain questions, the branch is not given out separately. They just write down in the bracket like this. So it will look like this, you know. So this is your branch. So always remember, if the longest chain has a double bond, triple bond, or the branch is there, we have to start numbering from there itself, or the nearby carbon atom is going to number as 1. So from here we are going to start 1, 2, 3 and 4. So 2 here is of methyl group. So we will write 2 methyl, and how many carbons are there? 1, 2, 3, 4. So 2 methyl butane. Remember, we are not going to count this also as the longest chain, because the longest chain or the parent chain is this only. This is considered as the branch. This is the branch. Okay. So on the 2 number we have a methyl branch. So we will count it as 2 methyl butane. Alright. Name and number the multiple substituents. So you need to name the number that you have already learnt about. You need to name them. How many methyl number are there. Then assign the correct position for double and triple bond like this. You can see what happens whenever there are double and triple bonds in the parent chain all together. So which one you have to give the numbering first. So what you will do, first you have to like this 1, 2, 3, 4, 4 number chain is there. So always remember, from here you are going to, from the double or triple, it's up to you. Like if 1, 2, 3 and 4. Okay. So now 4 is there, but 1 ene 3 ion. Alphabetical order of substituents. So what happened, you know, certain times butane first. So always remember to write the branch name first. Okay. So like here you can see, here there is a branch. So first we have written 2 methyl butane. So doesn't matter the M in the alphabetical order comes after B, but you always remember that you have to name the branch first. Okay. Give the number. Now use suffix for functional groups. Now you already know the suffix of all, like carboxylic you need to write oic, and for ketone on, like this, all, and this. So you already know that for functional groups you need to write the suffix as well. And cyclic compounds, we already know that you have to start with the branch name. Okay, carboxylic acid functional group preference first. When the parent chain have multiple amount of functional groups, you need to give preference to carboxylic first, then aldehydes and ketones, and then alcohols, and like this you have to learn. Okay, so you have to give preference to first all these first. All right. So since we already know the rules now, so let's try some namings of hydrocarbons, also known as nomenclature of hydrocarbons. So let us see the first question. As per the rules, we are going to try all this naming. So I will suggest that you keep your pencil and notebook ready, and let's get started together. So on the number one question, as you can see, is there how you need to count the parent chain, right? So as you can see in the parent chain, how many carbons are there? 1, 2, 3, 4 and 5. And there is no bonds are there. So means it's a single bond. So we can give it, we'll name it as pentane because it's from alkane. Okay. Now as we can see in the second one, 1, 2 and 3. There is double bond is there. So we will write it as propene. Okay, we are not writing one here, or you can also write here because it's understood that in the in the number one carbon there is a double bond, or you can write it as like this, prop 1 ene. Okay, now third one, 1, 2, 3 and 4. So butane, or you can write it as but 1 ine. This is alkyne. Now we will see this one. So you can see from the methyl, where is the methyl chain, you're going to count from there only. So you will 1, 2, 3 and 4. So it will goes like 2 methyl. And how many carbon are there in the parent chain? 4. So 2 methyl butane. Alright. Now the next one is this 1, 2, 3 and 4. So we will take it as 4. So but, you can have it butene, or you can give it a name like but 1e. Okay, either way is right. Now the next one, 1, 2, 3, 4, 5 and 6. So you can give it like this, hex ene. Alcohol group is there, 1, 2, 3, 4, 5. So you can give it a name, pentanol, or like this you can give. Either way is correct. Okay. Now we will see this question from here. 1, 2, 3, 4 and 5. How are you going to do this? See, in the 3 1 there are 2. So we will write it as 3 dimethyl pentane in this way. Okay, this one we will see first. Yeah, this one. So it will goes like 2. You can see 1, 2, 3, 4 and 5. So we will write like this, 2, 3 dimethyl pentane. And what about this one? You can see it's cyclo. So you can write 1 methyl cyclo. How many? 1, 2, 3, 4. Butane. So as you can see, this one you're going to write like this. You can see there is a functional group is also there. So we will write 3 methyl 2, and there is double bond also. Okay. So like this you're going to write. Now what about this one? How are we going to write this one? So this one is like 3 methyl pent 2 iron, because its triple bond is there. Then we will write this one. How will it is go? It will goes like 2 2, because you can see there are 2 methyl branches, pentane. Okay, now what about this one? 3 methyl, and you can see there in the branch, you can see there are how many? 6 are there. So 3 methyl, and there is 1 triple bond also, hex 3 iron. Now what about this one? You can do it like, you can see how many? 1 2 and 3. So 2 methyl, don't forget to put hyphen after the digits. 2 methyl prop 2 in 1 all. Okay, always mention the functional group as the one number. Okay, you always give preference to the functional group, then the double bonds, okay, or the triple bonds. Now this is the last one, 20 hex 4 iron. So these were the questions we practiced today. If you have going to have any sort of doubts, just comment down below. Any question you want me to try with you, just comment down below, and we will do some NCERT questions in the next part. Till then, keep on learning and keep on revising. Bye bye.